Hey guys, welcome back to another video, and today we're going to be solving the leet code question, the kth factor of n. Alright, so in this question we're going to be given two positive integers n and k. A factor of an integer n is defined as an integer I where n mod I is equal to 0. In simple words, n is divisible by I, okay? And we don't have any remainder. So consider a list of all factors of n sorted in ascending order. Return the kth factor in this list or return -1 if n has less than k factors. Alright, so what exactly does this mean? So over here we're given the number 12, okay? So what we're going to do first is let's just look at all of the possible factors of the number 12. So let's start off with 1. So 1 is a possible factor, right? So we have 1 over here. So 1 times 12 gives us 12. Then we have 2, which is also a possible factor since 2 times 6 gives us 12. Then we have 3, which is also a possible factor since 3 times 4 gives us 12. And so on and so forth, right? And this is the kind of list of factors we have for the number 12. But what we want to do over here is we want to output what the third factor is for 12. So in this case, the third factor, so 1, 2, and 3, the third factor over here is going to be the number 3. And that's why we end up outputting the number 3. Perfect. So another example, over here we have the number 7. Its factors are 1 and 7. And over here we want the second factor, which is 7, so we end up outputting that. And when we don't have an option, so for example, when n equals 4, and we want the fourth factor, the only factors we have are 1, so 1 times 4, then 2, so 2 squared, or in other words, 2 times 2, and then 4, which is nothing else but 4 times 1, right? So we only have 3 possible factors. So in this case, since we only have 3 possible factors, what's going to happen? We have less than k amount of values. So in that case, we're just going to output -1. So hopefully you did understand the question, and let's just start off by looking through at a very brute force type of approach, and then we'll see how we can actually further improve this, okay? So over here, we're going to start off with the variable called count. Now the count over here is going to tell us how many factors have we come across. So in the beginning, our count is just going to be 0. Alright, perfect. So our count currently is going to be 0. And now what we're going to do is we're going to go inside of a for loop. So over here, we'll do for number in range. So we're going to start off at 1. And we're going to go all the way up to and including the number n itself, right? So to do that, we're going to do n plus 1. Okay, so why exactly are we doing this? So at each time we're going to get a number and we're going to check if the number is a proper factor or not. And how do we do that? So to do that, we're going to do if n, which is the number we get over here, modded by num, so the number, so num is what we get here, is equal to 0. And if it is equal to 0, that means it is a factor. So in this case, we know it is a factor, so now we're going to check if we are at the kth factor. So to do that, we're going to do if count is equal to k. And if that is true, then we're directly just going to return our number that we're currently on. Now, if that's not the case, so if we do have a factor, but our count is not equal to k, then all we're going to do is we're going to increase our count by 1. And we're going to keep going through inside of this for loop. And there might be a point where we actually never even go inside of this, right? So our count or the k value must be greater than our count. So in that case, outside of the for loop, for that condition, we're going to return -1. So this is one way to solve it. It's more of a brute force approach. And now let's see how we can use kind of the same idea, but just simplify it a little bit. All right, so to do this, what I'm going to do is let's just go back over here. Now, these are all the factors we have for the number 12. So one thing I want you to notice is for getting to the number 12, we're basically doing 1 multiplied by 12. Another combination is 2 multiplied by 6. Then we have 3 multiplied by 4. So as you can see, you can kind of think of it as 2 lists. So to get all of these 6 factors, we have to go through everything from 1 all the way to 12. So let's just look at this. So that will be 6 iterations. Instead, what we could do is we could just go from the numbers 1 to 3 and get both of the sides. So what I mean by that is, so when we go to 1, we're going to add 1, and we are also going to add the number 12, right? Because we know 1 multiplied by 12 gives us the value of 12, right? So instead of going all the way until the ending, we can just find that value then and there. Same way for 2, once we reach 2, we can also end up appending 6. So that is going to be kind of the idea that we're going to be taking. We're going to be adding two values, a smaller value, which in this case would be 1, and the bigger value corresponding to it, which in this case would be 12. So that's how we're going to create our list. So in this case, we don't have to go all the way up to the value n. So how exactly do we know when to stop? So in this case, to kind of find out when we're going to stop, let's look at a condition where we have the number 4. So when you have the number 4, let's look at its factors. So you would have the number 1. And when you have the number 1, the other number that you would be adding is going to be 4, right? So 1 times 4 gives us 4. Then another factor we have is going to be the number 2. So in this case, 2 is a little bit weird. And the reason for that is because we're going to be getting a value of 2 squared. So realistically, just with this 1, 2, and 4, we would have two different lists. We would have a big value and a value or a list holding smaller values. So in smaller value, we would first add 1. And we're going to add its corresponding bigger value instead of big. So in this case, that bigger value is going to be 4. Now when we go on to 2, what's going to happen is we're going to add that value inside of both of them, okay? So this is one condition that we want to take care of, right? So we're adding 2 in both the areas. So in order to kind of take care of this, what we're going to actually end up doing is we're going to append our small and big, but we're going to ignore this 2 inside of big, okay? And that's only going to be the condition when we have a perfect square. Okay, but now let's just go back to the question that we were originally talking about. And the question is, until when do we go? So in this case, we went all the way up to n plus 1, right? So we got the number n itself. But in this case, what this is basically telling us is we're only going to go up to and including the square root of the number. So in this case, let's look at 12, right? So what is the square root of 12? So the square root of 12, I think is going to be 3 point something. So let's just check actually. Okay, so yeah, the square root of 12 is 3.46. And what we're going to do is we're going to go up to n including the number 3. So we go to 1. And when we go to 1, we're also going to add the number 12. So then we're going to go to the number 2, and we're also going to add the number 6. We're going to go to 3, and we're also going to add 4. Now, if it is a perfect square, like I said earlier, we're going to get a value where the value is going to be there 2 times. So in order to kind of make sure we don't have that, we could just add it in one of the places. That is one thing we could do. And another way we could do it is we could only consider one of them, right? So we could only consider the 2 inside of small. Okay, so one more thing, so over here we have, these are the big factors, 4 and 2, and the small factors are 1 and 2. So how exactly do we get all of the factors? So let's just make something called all factors, and all the factors over here is going to be the small value plus the reverse of the big value, okay? So in simple words, the small value over here, so the small values over here are going to be 1 and 2, so let's just add that. And now let's look at the big values over here. So the big value, first we're going to reverse it. So when we reverse it, we're now going to end up with 2, 4, and we're going to add this to our final all factors. But in this case, we're going to ignore the 2 since we're already considering it inside of small. So we only need to consider the 4. So 1, 2, 4, and these are going to be all of our factors. And now all we really even need to do is, let's say they want us to find the first factor, then we're going to return 1. For the second factor, we return 2. For the third factor, we return 4. But if it's anything like 4 or greater, then we return -1. Okay, so one thing that I'm going to do over here is I'm going to import math because we want to find the square root. So yeah, I'm importing math up top over there. But now let's go to our function over here. So let's start off by defining our 2 lists, which are big, and the other list we have is small. And they're both going to be empty lists in the beginning. So now what we're going to do is we want to iterate over the numbers, right? So for number in range, and what is the range going to be? So we're going to start off at 1, and over here we're going to find the square root, so math.square root of n. So we're going to go up to this number. But one thing that we want to do is we want to include this number as well. So to do that, we're going to do +1, okay? So we're going to include this number as well. Perfect. Okay, so we have this, this is the range of numbers that we're going to be looking for. And now we want to check if this number is actually a factor or not. So to do that, what we're going to do is we're going to do if n mod num is equal to 0. And if it is, that means that we do have a valid factor over here. So now over here, we're going to have one of two conditions. So what we're actually going to, two numbers, right? So what exactly are going to be the two numbers? So one of the numbers is going to be num itself. So this over here is one of our numbers. But what is the other number? So the other number is going to be n divided by num, okay? And how exactly do we know that? So if num is a valid value, it means it is divisible by it. So let's say num is 2. So 12 divided by 2 would end up giving us the value of 6. So all we want to do here is we want to find out which one is the bigger one, and we're going to take the bigger one and append that to our big array over here. Okay, so one thing we're going to do before that is we're going to check if our number over here is equal to n divided by num. And if it is equal to the same thing, that means that we have a number which is a perfect square, right? So number is equal to n divided by num. Okay, so in that case, we're only going to append it to our small list, okay? So small.append num. And if this is not the case, then what we want to do is we want to append it in both the places. So we're going to do small.append, and over here, what are we going to append to small? So at small, we're going to append the minimum value between the number and n divided by the number, okay? And we're going to do the opposite for big. So let's just copy it over. So for big, we're going to append the maximum between the number and n divided by the number, okay? Perfect. So that's going to be it inside of this statement over here. And now let's go outside of our for loop. So outside of our for loop, like we saw earlier, the first thing that we want to do is we want to reverse the big list, okay? So to do that, we can just do big.reverse, okay? So now we reverse everything instead of big. So now we have both of the values. So we have the smaller, so we have everything inside of small, and we also have everything inside of big. And now all we're going to do is we're just going to add them both together. So let's just call this all factors. You don't necessarily have to add it, but I'm just adding them together because I think it'll be a lot easier to understand. So over here, inside of all factors, we're going to have the small list, and we're going to add the big list to it, okay? So small plus big, that's all of the factors inside of there. Okay, so over here, now all we need to end up doing is we want to return whatever is, so what are we going to return? So we're going to go to all factors, and we want to return whatever is at k minus 1. So the reason we're doing k minus 1 is because the first factor is going to be at the 0th index. So we're going to do k minus 1. And we want to return this value. But before we return this, we want to see if we can actually return it, right? So what I mean by that is the length of all of our factors. So inside of that list, so all the factors has to be greater than or equal to k. And only if that is the case, then we can return this value over here. And if that is not the case, what we're going to do is we're going to end up returning -1. So this should be it for the other way to solve this question. And as you can see, this submission was also accepted. So yeah, finally, thanks a lot for watching, guys. Do let me know if you have any questions, and don't forget to like and subscribe. Thank you.